He is a founder of GT Instruments Berhad. He also has 20 years of working experience in instrument company, specializing in testing, support service, and training. His vast experience has been in areas of static load testing, complying with international test standard. He will, sorry, he trained at various places in overseas, to name such as Taiwan and UK. So, without further ado, it's my pleasure to invite Mr. Ng Fu Sang to share with us the potential and future trends of packaging engineering.
Thank you, Mr. Shafi, and thank you very much for UDSM for the invitation, and also an opportunity for me to share some experience of this packaging engineering. And for shorten the time, I will proceed on my slide. Can you hear me? Excuse me. Can you hear me?
Yes, loud and clear, sir.
Okay, this is my slide. Basically, we are talking about packaging engineering and future trend. What will be the future packaging engineering and future trend? And that is a part that actually, when each time when I'm meeting a lot of students, or even a lot of these packaging industries, and they actually know very little about packaging engineering. They only know about what is actually the we just follow the QC, or what is actually customer required. Basically, packaging engineering is more than that. Okay, this is the one I need to tell, from my experience and contacting with a lot of industries. And this is what I get to know, and I will share the experience. Basically, for introduction of this, before we move in the topic, let me to introduction our companies. Myself is from GT Instruments and GT Group of companies, and the company actually provide a total solution for testing laboratories. What are these total solution is? Actually, being a company, I'm actually a company, actually we are selling equipment, and we do install, of course, we need to install machining of the machines. And lastly, of course, you need to do maintenance. This is actually very basic. And very importantly, I think we noticed that some of the thing is actually equipment purchase. And a lot of users having some difficulties that the equipment is actually being calibrated or accredited, where they have difficulties. And they always get another party which is actually not accredited, or accredited, they are not familiar. This is how actually we come in to assist. Then later on, you can see some slide why is actually accreditation so important, or validation is so important. And lastly, also a company also providing a lot of trainings, which is something like HRDF training and so on, relevant to the accredited trainings. Okay. Okay, what is actually packaging engineering? I think probably yang saya fahamkan banyak student, especially student saya jumpa kan, dia orang tak faham apa yang packaging engineering. Dia just tahu, okay, benda ni dia just nak, just get design, just test saja. Sepatutnya engineering ni dia nak develop and optimize the protectkan itu sistem, atau dia nak make sure kan equipment, especially yang produk yang being for not spot kan. That's why this is involved on, if packaging look into packaging detail, dia ada termasuk mechanical dengan chemical. Contoh kan, kalau dia mechanical ni, contoh dia compression testing semua ini mechanical atau design. Tahu chemical dia involved on material dalam tu, yang bagaimana make sure dia fresh. That's why dia, if you're looking at packaging engineering, dia a little bit complicated sebab dia yang coverage quite wide. That's why you can, from this topic kita nak tahu. That's why packaging engineering actually very innovative sebab dia kena tahu what is actually necessity or what is actually applications. This is what I call packaging engineering. And also, this is what I just mentioned about chemical engineering. Why they involve chemical engineering dengan mechanical engineering? Sebab they make sure kan itu produk ni, the packaging ni, dia nak secure, yang especially very important that barang kan sampai ke customer yang safe, and then not only safe, then make sure dia yang kalau food tu make sure yang fresh. and is actually consumed by end user. That's why dalam whole process tu, there's a chemical involved dengan mechanical. In mechanical dia lagi banyak sebab dia involve through, kalau for overseas, from overseas, dia ada termasukkan not only packing, sebab dia akan go through truck atau railway atau air freight. That's why dia akan go through yang several of procedure atau several transportation dan masuk heat. That's why dia ada too many possibility yang cause kan itu products yang failure. That's why yang packaging engineer dia akan engineering atau engineer tu dia make sure yang barang tu secure, yang no damage atau spot, especially the product dalam tu. Based on according to research by Smith, the future packaging long-term strategy is 2018. This is actually global on packaging increase expanded to be achieve 1.2 trillion. That's why you tengok tu dia punya potential untuk yang packaging very wide. Kalau you tengok betul-betul untuk industri, especially electronics, dia nak looking for packaging engineers sebab dia nak involve, dia nak make sure orang yang boleh design, then design untuk appropriate packaging. Satu lagi appropriate packaging, make sure dia yang jimat. Of course, cost is one of the important cost. Then certain thing also have to make sure that dia punya material boleh sustainability, then atau ikut consumer trend dan brand own trend. Lagi pun last one dia nanotechnology. Sebab what is nanotechnology? Dia nak develop nanotechnology, dia boleh trace. Maksudnya barang tu dia nak pergi mana, dia boleh trace. This is also one of the nanotechnology coming in for these industries. That's why dia untuk packaging engineering atau packaging engineer, dia involvekan banyak. Dia nak tahu little bit on here and there and so on. That's why for this one, before I move forward untuk yang dia punya trend atau dia punya necessities, of course, kita nak tahu a little bit on, for this case, I will take some cases for study on understanding of corrugated fiber applications. Sebab yang corrugated yang widely used in these industries. Okay, I will try to introduce a little bit what is actually corrugated applications. Okay, sorry for that. Okay,
Yes,
before we moving forward, I think the first thing I need to introduce a little bit of corrugated fiber applications because it's very important to understand some basic of the corrugated fiber board and move on the what is the future trend, what actually industry required. Okay, based on this one, you see there are few introduction about the corrugated and packaging and also we call it a box packaging and engineering and testing as well. Okay, I think basically look at it on the packaging on the corrugated, look around. And corrugated is actually a way. I think it's very popular in in most of the things, especially nowadays a lot of these courier service, the online purchasing and so on. They consist of a lot of packagings, and this is what we call why corrugated is actually withstood to be test time as well, and why it should be used and practically useful economy and renewable recycles, and also because of lightweight, very important. So, to make it easy, that's why you can see in corrugated, as you know why they call it corrugated, because you can see there's a floating, and there's actually one floating. Why they have a floating? Because actually they can sustain certain energies. Okay, sustain energy will protect the products, which actually they call to call a linear port, where they have a floating, and you can look at it basically how this manufacturing a paper board and corrugated base. Normally, you will be go through two process. One, you have to go through a paper mill where you can see a paper roll. Then after that paper roll will supply to the paper board corrugated manufacturer where they're going manufacturing on the corrugated board. This is actually very basic for the process. And you come to paper board and corrugated board. They have this is how the corrugated being manufactures. Okay. They have a heat, and then they go through, and then they have actually another paper coming in from the other single phase. They're making the float where they have a glue and then come up, and at the end, at the medium, they come in the correction where actually there is also another moisture heat to remove. And this is how it basically a single wall, okay, single phase stations, process on single phase process. And basically this is how the process, how the product is look like. And then for double phase, double stacking or double float, single phase, single float or single wall, basically you can see that probably you can see total 3 paper, meaning that one is for the other layer on top, and then one is floating, plus another one is actually lining again for cover. That's why you can have a complete. This is called a single wall manufacturing process. You can see it's single wall. And this is how the process is. And plus, you can see if they are floating, why they have a certain floating. This is also very important and also interesting as well. And you can see why is the length of the shape, toe line, and so on. This is actually typical single wall paper, where you can see the floating direction and so on. And that is how they are actually corrugated float beam manufacturers. And when you come forward a little bit of the structures, you see basically this is how actually paper board beam manufacturers, where they have a design and so on. How this design come in? This is actually their we call it packaging engineering coming in, where they have to design appropriate box, where make sure that the box is actually not too large and not too small, where you can accommodate with the thing and make sure it's protect the item, means protecting the item or the products. This is how they actually the structures normally how we make. And then you can see the structure on this thing and how this one, and when it comes to process, basically it's 3. One is actually box structures. The other one is actually package engineering plus the graphic design, printing and finishing before you can actually come into the end products. This is the whole process, total of the 3 whole process to complete for the corrugated boxes. Okay. Plus, and also they have corrugated structures. Then you can see why the actually corrugated fiber or combined board has 2 components, where you can see why they're component, because actually they have certain function on these, corrugated. Why they have 2, they have combined board, because you can see from there, the floating actually for engineering design, you can actually determine that the float actually this is a suspension, where when any of the vibrations on, they protect the components of the products inside the packaging. That's how we call it. Instead of you actually make it very huge or put a lot of cushion and so on, and this basically is fantastic because just floating for single wall, and with the floating it can protect the products, and with very lightweight, very importantly, because when especially you want to go for send for overseas, especially on air freight, and weight is a very concern. Weight is always very concerned. And come to float again, you can see basically they have 3 several types. One is single phase, as I mentioned, where single phase you have only one phase and then floating. And single wall, you have one phase, floating plus another phase again. This is actually single wall. When you come to double wall, you can see total 2 floating and 3 phases. And of course, later on, they will have a new technology is coming in triple wall, and triple wall is getting very popular. They're using this for pattern. Use triple wall because it's much stronger. Okay, triple wall. And come to this corrugated, you see why all this corrugated, because they have number. You also notice that they ada banyak floating. They untuk A, B, C, then E float. Why all this floating coming in? Then they have everyone have their own function, their characteristics. That's why they come in, because this is how the design come in, and they do some research. That's why they are coming very floating. It depends on every different applications. For example, this is a single wall. This is a sea float. And sea float, you can see there's actually single phase and also medium and so on. And also using different paper. For example, 33 pounds, 26 pounds, and 42 pounds. This is one of the typical sea float of corrugated board. And then, at the end, they call it 101 pound single wall. This is how normally kita calculate. And another one is double. For double wall, you can see there will be 3 liner board with 69, 42, 69, plus 2 medium. Okay, B float. They're using B and C. And one is B and C, they have a different dimensional. Okay, floating size. That's why they're using 26 pounds paper for sea float. And this is actually referred to 275. I generally refer to 275 pounds. Okay, PC double wall. Okay, for floating servo size, there's the A float was original float profile for corridor, but it has 33 float per foot. That's why kalau you nak tahu kan apa is A float, it's actually calculated based on floating, 33 float per foot. Floating. If P float, you nampak dia more float, they're up to 47 float per foot. This is how they call it P float. And for C float, you can see only 39. Okay, 39 float per foot untuk C float. And of course for C, E, like more, it's much smaller. You can see E is much smaller, and 90 float per foot. That's why this have to understand. And the E float is actually even smaller, 129 5 float per foot for corrugated. Okay, this is E float. And of course, we all talking about this packaging engineering. What packaging engineering supposed to do? Okay, they need to do actually basically they have to design, because since they have so many float A, B, C, and so on. First, they have to understand the characteristics of each float. For example, they have to know the product form plus the product characteristics. What is actually requirement? Then finally, what is actually product? Then after that, they will try to design for using appropriate, the floating plus the size. Maksudnya dia punya structure. What is the size? This is actually physical structures, mean actually product form. You can be physical nature or solid or fluid. That's why you have to depend what sort of things, and we can from there we can actually determine apa yang kita nak pakai, atau kita nak guna yang for example kena yang kalau untuk solid, then what is actually the cushion? Okay, what is the cushion? What is the fluid to be used? And also fluid. If fluid, then like gases and flow, of course, they need to another enclosed, for example, package, plastic bag, or certain of the what you call it, other than plastic. I think you can use this is what I call small tankers, where you can protect the tankers inside the fluid. If you're using fluid products. And corrugated engineering products, okay, if you characteristics, you have to base on shape, and then you have to base on what is actually then make sure is it corroded or adhesive or cohesive, and also contaminations. Is there any can cause contaminations, and also is it actually light sensitive? Is there any sensitivity? Plus, also you have to know is it any magnetic field, for example, electronic part, their magnetic field also provide concerns, and also. They also have another, of course, light sensitivity. They have two types of light sensitivities. One is visible, one is the other is not light not seeable, like infrared and so on. And also like abrasion, is it cause abrasion? If kalau kita nak pakaikan itu packaging, is it easily abrasion for the product actually moving dalam tu? And for following factors, that's why for this. Kalau untuk design engineer, other than this floating and this detail, then kita nak count dia punya arrangement of the products dengan orientation, okay? Dengan make sure that dia avoid dia may crash, ada abrasion, ada puncture. This is one of the things kita nak arrangement bagaimana how you gonna arrange. Sebab this is also another packaging engineer kena look into. Sebab this is not only packaging in the complete. Kita nak make sure juga dalam tu orientation. And then for this one, this is also after all this detail, kita move forward to transportation. Kalau kita nak hantar barang from destination A to destination B, dia akan go through several things. For example, transportation mode. Apa yang transportation mode? Contoh kereta, truck, railway, airplane, kan? Itu yang transport. What is a transportation mode? And then what sort of testing? They have any compressions? Contoh you nak stacking, dia ada compression. And another, any shock. Shock maksudnya dia untuk truck atau untuk railway, dia akan vibration. Sebab shock juga, dalam dia shocking. And ada hazard tak? Dengan ada apa-apa carrier punya rules, kita nak follow. That's why this is the thing kita nak tengok into all this and packaging engineer kena look into this part as well. And we will talk about this thing later. Kita akan talk a little bit more lah dalam untuk yang untuk compliance. And also for transparency mode, kita ada basically we have few type. One is actually their model freight, satu real, satu ship. Okay, this is actually their most common type that we are using. A, an intermodal, and also overnight and small parcels. That's why this is the thing kita nak tahu apa. So just now kita ada bincangan transportation mode. This is the mode kita nak tahu. Okay, what is actually TOFC, bagi apa? Trailer to a flat car, atau container to the on flat car. So this is the thing kita nak tahu. Okay. And so second one, carrier rules. What is carrier rules? Sebab every country dia ada yang limited, dia ada certain rules. Kita nak tahu which is actually appropriate atau tak appropriate. Kita nak follow. Make sure kita make design meet the local authority atau they make carrier rule have been specified, especially untuk certain hazard barang. Contoh gases semua ni kita nak make sure. That's why kita nak go through and the design appropriate tak atau dia protect tak. Once you have this thing put in the consideration, then kita masukkan actual testing. Sebab kita sudah nak tahu design, kita sudah determine all these thing. Kita akan go through yang compression test. Compression is one of the very basic testing. Maksudnya dia ada dua option. One is actually static and one is actually cyclic. Okay, cyclic. Or ada dengan apa? Stacking pattern atau parallel type of condition. Kita nak tahu. Then this is one kita nak test on these machines. Sebab why dia nak do this compression? Sebab dia nak go through this process simulation. Dia nak buat exactly simulation. Macam tadi Encik Maslan dia cakap atau yang doktor tu dia cakap yang buat simulation tadi CNC kan. At the same time ini pun sama juga. Dia kena kalau boleh buat simulation, then sepatut then followed by actual testing. Sebab dia nak tahu actual situations what is going to happen. Dia nak tahu untuk packaging yang boleh kan dia possible yang boleh protect products atau safe. Compression is one of the other chemical tests. Shock, another one. Shock is also another one. This is shock meaning that from item kalau they drop, what is going to happen? Barang boleh rosak ke atau which one is standard? That's why shock ni dia kena dalam testing. Dia nak tahu juga untuk drop test atau dia sebab dia mechanical handling, manual handling dia ada berbeza untuk shock testing. Dia nak determine. Then other hazards that contoh dia ada vibration, puncture, temperature, humidity, pressure, corrosion, energy, atau contamination, strain atau time. Ini one of the other hazard kena dalam consideration untuk kan testing packaging. Dan lastly itu stacking test. One usual test kan sebab tadi yang untuk individual. Then what happen to stacking and compression? Maksudnya dia stacking. Saya nak stacking 2 ke 3. This is actually on the warehouse atau untuk transport. Dia nak tahu yang apa yang boleh sustain. Dia tak boleh kan simply saya letak aja. Atau dia tak boleh based on satu, dia consider boleh stacking. Sebab stacking test untuk yang single test, untuk double test is different. Totally different. That's why dia stacking dan compression dia kena check juga. Untuk benda ni, kalau stacking test, dia make sure yang safe. Sebab I think several issue ada berlaku di warehouse. Sebab barang tu dia tak boleh sensing, dia fall down. Lepas tu cause itu yang the workers yang injury. That's why jadi this is very important. That's why dia nak check yang stacking ini compression. Yang engineer ni dia kena tahu what is actually stacking test, stacking and compression test, what is actually their value. That's why in the distribution on another satu lagi untuk distribution environment in the container performance. Ini pun kena look into this one as well. Sebab dia punya, especially di Malaysia, kita high moisture. High moisture. That's why moisture tu paper yang paling takut. Sebab paper tu absorb moisture. One dia absorb moisture. Jadi dia weaken. One weaken, dia boleh cause collapse. That's why on this case, kalau distribution kita tak tahu dia berapa hari semua ni, kita nak buat simulation. Kalau untuk this condition, well, this packaging is safe. Okay, kita nak buat juga on all this worst scenario, what's going to happen. That's why kita nak check semua benda ni. Then kalau dia tak lepas tema criteria, then engineer kena come back lagi, kena redesign balik untuk dia punya enhance it, untuk make sure dia boleh withstand Okay, untuk withstand. And this is one of the criteria they have been given like compression loss sebab untuk 10 days. Okay, 37%. Kalau storage time and under load. That's why you tengok dia ada factor. Bagaimana yang kita dapat factor ni? This is all are been tested. Okay, by universities. Normally university. Dia akan buat testing semua ni at this condition and so on. What will be their factors multiply? Then dia kena tolakkan. This is actually for make sure kau. Sebab untuk industri, dia tak boleh tunggu. Tak boleh kan saya buat packaging untuk nak tunggukan 10 hari atau 30 hari. Baru test. Dia akan minta satu research. Contoh, especially like university, dia boleh buat research. Kalau untuk this design, untuk 10 days as this first scenario condition, what is going to happen? What is the factor kita nak multiply? Okay, untuk yang safety, untuk yang packaging yang safety. This is one of the chart untuk environment factors. Then another one untuk determination of the compression on compression requirement. That's why dia ada stacking, dia ada formulation juga untuk kalau egg box what is going to happen. Sebab dia kena multiply certain factors. Dia tak bolehkan untuk berapa hari sini. This is all formulation available. Sebab itu benda ni semua yang research dia ada dapat value ni. Then this is how you gonna apply. Then you apply based on that. Kita tak bolehkan contoh kita nak stacking untuk 10 carton, kita nak test 10 carton, it's not possible. This is actually how the research lab dia sudah buat. That's why dia come up with formulation atau factor. Then this is factor we come in, then we multiply. Then come in, how safe is this for berapa hari untuk this condition. Okay, this is how the compression requirement untuk extreme static loading. Then untuk solution ni, that's why kita nak enhance. Kalau untuk benda ni, kita akan based on this data, kita akan improve. Kalau dia tak boleh achieve, kita mungkin kita improve, ambil yang higher, stronger, linear atau medium box. Kalau dia tak boleh sustain atau dia easily below the criteria, contoh kita nak modify atau improve dia stacking, bagaimana stacking semua. This is actually engineer kena buat. This is actually all this time dia orang buat manually, tapi sekarang tu sekarang ada yang simulation software. This is much easier untuk yang dia orang boleh buat simulation. Nanti saya akan bagi certain information untuk simulation. And this is a solution untuk yang compression. Okay. Plus also the compression. Then lepas tu ada testing shock and compression. This is one of the shock and compression. Maksudnya dia letak sampel ni, what happen kalau the shock and vibration. Yang produk ni dia safe ke tak safe. This is one of the another thing. Kita nak make sure kan produk yang safe. And benda ni normally engineer dia kena ada machine ni untuk testing. Atau tak ada, dia kena cari yang research lab atau yang testing lab yang dapat information untuk yang develop, yang make sure kan produk safe ke tak safe. And one of the thing is untuk ini shock testing atau compression ni, kita nak complete item. That's why this is one of the things that kalau kita hanya yang dapat equipment, kalau kotak kosong je, is not workable. Sebab kita nak complete. Kita nak complete baru boleh buat actual simulation. Untuk shock and vibration test. Okay. From there kita nak tahu dia punya tag, dia acceleration apa, dia punya energy apa. Kita nak determine how safe is the product in the packaging. Or the packaging, how safe to protect the products, or the barang download. And then you can see actually, we can see from this vibration, we can understand their vibration, whether actually the frequency and the acceleration, so how both common and most actually, how bad is actually impact. Kalau dia drop, dia punya packaging ada rosak ke mana terosak ke, from there kita improve from there to enhance untuk yang tempat yang very weak, kita nak improve. That's why this is actually kita nak tengok. Then of course this is not only packaging itself, kita nak tengok barang first and then follow by packaging. Kita try to minimize dia punya impact untuk kalau in case dia berlaku, barang dia berlaku. And also for contamination, this is actually involved on chemical engineering. This is actually how make sure that their contamination minimize. Okay. Kalau cross contamination, it is very serious, especially untuk food. That's why dia kena check kan dalam tu packaging yang dia punya benda ni dia protect tak. That's why dia, for this case, untuk contamination, biasa dia kena look into this part, what is actually the part, and any sensitivity. Kalau most of cases untuk contamination, dia akan guna yang plastik, yang cover untuk produk ni, to minimize the contaminations. Okay, and also from this also, you see there boundary resistance. This is also one of the things actually we have to calculate where is the weight and so on. We have make sure that dia kena strip, yang barang-barang tu strip. This is all engineer kena design. Kalau strip tu dia akan enhance dia punya packaging untuk produk dengan packaging sekali. Instead of just stacking je. Okay, it's just stacking je. Lastly, dia tengok dia ada jenis design tu. Dia tengok kalau oversize tu on certain thing is actually not recommended. Okay, ada certain stacking tu, certain safe, certain not safe. This is the things kita tak recommend. Ini dangerous. That's why kita nak make sure dia dalam within dia punya palette kalau possible. That's how and then equal. So this is how actually to protect their only products, then enhance dia punya property, the characters. Maksudnya packaging punya property, then enhance juga. This is how the warehouse kita kena effective unitizing. This is actually also important by the engineering. Yang packaging engineer kena bagi tahu information how you gonna stacking, how you ensure that this one can lasting longer and so on. And this is also make sure they are minimize, they actually maximize the space for more products to be safe dalam their warehouse and safe as well. That's why this is all under unitization. And this is also from unitizing system as well. Kita nak tahu dia punya footprint, contoh dia punya clamping, parrot atau slip sheet. Sebab this is one of the things that kita nak tahu kan parrot. Kalau parrot tu, kita make sure dia yang properly insert. Sebab kita nak takut dia slippage. Sebab sama ada slippage also in cause ada issue juga untuk kalau industri. Kalau slip sheet, sometimes dia guna slip sheet ni untuk yang dia moving. Okay, untuk yang lift truck atau pulley, pull on the flat pallet. This is one of the new technology. Bukan new technology, actually dia quite previously dia ada pakai tapi tak banyak. Sekarang dia become moving to this slip sheet untuk moving. Sebab dia akan movekan produk easily or under certain parameters support. You can see this is how you want to pack, because this is actually dia kena minimize dia punya space. Instead of kita terguna apa? Yang solid punya pallet. Sebab dia nak slip. Ini one of the new technology you mentioned juga. Dia panggil slip sheet. And clamping, this is what actually the clamping as well. Just make sure packaging yang clamping, bagaimana clamping, atau dia try to avoid. Just previously biasa kita letak tape aja. Sekarang dia letak clamping untuk enhance dia punya apa? Dia punya kotak untuk protect dia punya products dalam packaging. Okay, basically this is how this normally they call it a column and so on. Okay, I think basically application for these packagings. There's actually a number of slides on about these compression losses and so on, and stabilities, for things and so on. This is how you want to improve. Now I want to continue with my slide for the other slide again. Okay, we come back to this one. Come back to this future trend. One is actually when I'm meeting a lot of customers, especially now electronics, because actually electronics, the cost of their components are very expensive. Now there are few issues, the impact for their packaging. First thing, what is that they call it a problem statement. First thing, they try to waste reductions. Bagaimana kan dia nak reduce, that's why dia nak engineer design such a thing that dia nak minimum basis or reduction. Dia tak nakkan satu barang untuk yang big packaging. Dia tak nak. Number two, how you ensure dia punya safety untuk packaging yang safety. Yang at the end dia yang safety. This is the impact. And also deteriorations. This is one of the things that is open deterioration, like caused by this, like heat, cold, bacteria and so on. And number four one is actually physical. This is actually we are talking about the go through and transportation from one location to another station. This is called a physical production. How this is actually packaging having the big problem for these four factors or four problems yang engineer kena look into. That's why this is the one kalau kita nak jumpa yang banyak industry, especially electronics, dia highlight these four items that impact. And then kita nak design, come up, engineer kena design, packaging engineer design. That's why the new trend, they come in. Then they always ask, what can we do? I say the only thing is packaging testing. Why is packaging so important? Packaging yang penting. Sebab testing compress actually dia ada wide range of testing. Kalau you tengok dia pecahan four factors. Kita nak go through various testing untuk nak validate. Okay, nak validate kan yang ini boleh withstand ke tak withstand. Termasuk tengok dia punya transportation atau environment. Okay, dia durable tak sampai barang ke end user. That's why kita make sure yang packaging tu safe. This is very important. Why is this testing? Is actually make sure the products sampai end user yang safe. Okay. Second one is actually important of the packaging testing is actually packaging testing, ensuring that the packing will be protect your products and damage during the transportation and distribution. That's why dia nak minimize kan kalau tak ada damage. Okay. And packaging testing also reduce the packing, identify appropriate protection level. That's why dia ada level. Later kita nak nampak dia ada level, safety level. What is actually dia punya apa? Not only safety level, criteria, acceptance criteria, amount of the products criteria. That's why this is one of the important of testings, packaging testings. And then hanya kita kau buat testing je. How kita tak boleh kan just test untuk shop sendiri je. Kita nak make sure testing yang kena validation. That's why yang testing and validation is very important. Make sure kan barang tu kita test ikut appropriate test method. Dengan dia ada how you validate yang testing yang kena validation. Make sure yang barang-barang tu ikut dia punya criteria atau dia punya procedure. Contoh sampling, condition dengan equipment yang kena comply with dia appropriate standard. Contoh apparatus accuracy. Then dia punya test procedure atau sample condition kena ikut, then test procedure, then reporting. Okay, reporting. And then what is the type of testing kena buat? This is the later on. That's why what need to highlight is testing is actually validation. You have to validate to in order for make sure dia yang apa yang test result tu boleh terima. Okay, boleh terima. That's why testing is a key. As I mentioned, kita highlightkan banyak tu. Testing is a key. Okay, there's no other thing. Testing is key. This is how we are to get the detail from the to simulate to test thing. Dia boleh withstand ke tak withstand. And important packaging testing. This is actually after you test it, dia very important is what? Trust. Sebab once you got the data, kita boleh justify bagi tahu kat customer. This is how safe. Sebab untuk kita tak bolehkan buat benda ni sampai tu. Sebab lab packaging engineer tu atau lab tu dia hanya buat testing. Dia bagi yang data. Yang data ni kita boleh tunjukkan ini data how safe. Dan kita buat all this detail kena evidence with all this procedure evidence. And this is actually important of packaging testing. And common type of testing in mechanicals, okay? In mechanical, what is a mechanical testing? Kalau untuk packaging, first thing, vibration, okay? Sebab di vibration kita nak go through kan dia punya apa? Contoh ocean freight atau dia punya trucks atau dia punya air freight. Dia semua itu yang panggil vibration sebab dia akan vibrate. Okay? Nombor dua, dia impact. Kalau dia benda-benda ni dia akan drop. Okay? Dia incline while weapon dia strike. Dia ada rosak tak? Atau packaging ada boleh rosak atau dia punya produk safe. This is the one kita nak buat. Ini mechanical test. And another one is actually drop test. Sebab kadang-kadang dia mungkin very high possibility dia drop. Kalau in case drop tu, barang tu safe tak? Kalau drop at certain height. Nombor dua, what you can drop is dia yang benda ni yang packaging ada rosak tak. Sebab kita nak end user tak nakkan receive barang tu kotak ni rosak. Okay, dia pun tak nak, even product dia okay. That's why kita make sure design tu, engineer design make sure dia kena safe. Okay, sampai ke end user. Then climate is also another one. Dia kena make sure sebab kita go through, tadi kita dah explain tu, every country different climate. Then dalam transportation pun ada climate juga. That's why kita nak test kalau go through this climate, what is going to happen? Bagaimana dia condition kalau go through this climate, will the product safe or kotak masih safe lagi? Kita nak tahu. And load. Finally, kita sudah dapatkan semua ni, all this detail, kita go through load. What is this load? Maksudnya, kita nak boleh buatkan, kalau boleh, kita buatkan stacking test. This is called stacking test. Another one is very common one, they call compression test. Ini untuk static, untuk satu je. Tadi saya tak tunjuk. Sebab you nak stacking test untuk 6 or 7 tu, I think it's quite difficult. Untuk contoh ini, 3 je. What will happen? Kalau dia same load untuk certain time, dia tengok yang bawah akan rosak. Sebab barang semua sama. That's why dia nak tahu how safe. Kalau berapa lama kita boleh stacking, berapa load boleh stacking, then how long? How ensure that ini yang safe. That's why ini kena ada factor. Tadi kita dah tunjuk ada factor. This is how I actually explain to industry. And then dia buatkan satu static test. Then at the same time, dia letak the factor, then dapatkan how, then dia boleh work out dia punya safety. Untuk safety, load tu. And finally, untuk kan computer analysis, sebab kita ada susahan kalau untuk kan just buat satu pokok, satu carton je, kita nak buat testing. Now the new technology, bukan new technology, dia guna simulation. Sebab contoh yang Intel, dia ada bincang dengan kita. Kita nak satu IC, kita ada satu IC, kita nak letak dalam 20. Can you design? Tapi nak design tu, you takkan work out satu. Dia nak make sure, kita nak buat simulation. Buat simulation, how safe is the things. That's why kita, sebelum kita nak come up with actual, kita akan buat simulation dulu. Kita buat kotak, letak benda-benda ni, then dalam tu, kita akan buat simulation. How safe, kalau packing macam ni kena tunjuk. Then this paper, fruit A, fruit B, fruit C, and then how big the thing is going to be this thing, kita nak keluarkan. Then kita ada few option untuk bagi user. Contoh kita nak fruit ini, this is the how, this is the cost. This is the cost A, cost B, cost C. Then user akan decide, okay, kalau cost A ni, what is a protection, what is actually safety level. Cost B ni, this is the protection level. Then cost C ni, then dia akan decide which one do you want to go. One dia decide, dia tengok okay, dia tengok yang, kalau contoh kita ada 5 solution untuk yang computer analysis, ada 5 solution, 5 solution, dia akan pilih 3. Then dia akan suruh manufacturer akan buat actual. Dia akan buat actual kotak, then kita buatkan, ambil actual, kita akan buat testing. Buat actual testing. Buat actual testing, kita confirm balik yang apa yang computer analysis dengan actual tu, ada sama tak? Ada berbeza. Kalau biasa ada berbeza saja, sebab dia punya factor dia ada lain-lain. Contoh dia ada lain, contoh stacking dia lain, dia apa? Dia punya condition sebab floating pun ada takkan 100%, dia takkan zero factor. No way lah. Dia ada factor juga. That's why kita dapat berbeza yang packaging engineer akan berubah. Dia akan dapat satu safety factor untuk dalam tu multiply untuk dapat from the FEA dan masukkan itu safety factors. This is actually computer analysis lah. One dapat ni kalau then finally, apa yang dia orang buat? Dia nak buat performance testing on shipping container and system. That's why tengok dia ada satu, dia panggil apa? Distribution cycle. This is one of the standard. Dia ada tunjuk. Contoh kan. Sebab ini kita tak boleh kan kita buat sendiri. Kalau kita nak buat sendiri, kita punya cycle, distribution cycle, kita boleh buat. Hanya you nak kena validate. That's why yang standard tu dia keluar. Contoh kan, dia ada distribution cycle. Dia ada TC. 1, 2, 3, 4, dia ada lain-lain. Sebab each of everyone, dia ada lain. Contoh, untuk general cycle, dia underline distribution system. Atau schedule based on A handling. Schedule D untuk shock vibration. Atau schedule F, G, J, A. This is what actually the process you gonna test. This is the appropriate test you gonna carry out in order for you to satisfy. Okay, this is one of the, ini yang dia apa? Yang come up, dia panggil apa? Distribution cycle. Untuk distribution cycle. And from distribution cycle kita akan tertunjuk, okay, QFTL trucks atau the car atau apa dia punya then lastly dia akan define, dia dapat benda ni dia akan define unit, establish dia assurance level, okay, assurance level dengan acceptance criteria. Contoh acceptance criteria number 1, products is damaged. Number 2 ni product is intact atau dia proof criteria. Dia kena list down untuk yang testing ni. Dia panggil performance test. Dia akan determine. Dia panggil apa? Determination acceptance criteria. Lepas tu kita nak select distribution cycle yang tadi saya tunjuk. Okay? Dia ada 1, 2 numbers. Dia ada yang sudah validate. Yang validate. Then kita nak prepare untuk write test plan. Okay? Untuk test plan. Contoh, this is one of example test plan untuk yang test package untuk commercial products. Contoh, saya punya value tu moderate value atau dia punya volume of shipping, typical product shipper untuk shipper line no damage. Okay, kita nak prefer no damage. Then lepas tu kita nak make sure dan dia make good condition after the test. Fiberboard ni weight 160 pounds, 73 kg Then lepas tu dia punya dimension height, dimension tu. Then stack two height on pallet for storage and truckload shipment. Fiberboard container is 275 psi burst grade materials. Then customer storage pallet load too high product. This is actually their next statement. This is dia akan bagi tahu, oh this is saya nak buat macam ni, saya nak product commercial products. Then what you want to do? Then kita nak start to prepare to give kita nak testing plan. First kita nak define dia shipping unit. What is shipping unit? Actually testing dia punya apa? Pallet load, typical pallet load. Then number 2 dia punya assurance level. Then determine dia punya acceptance criteria. Okay, criteria no product damage. Okay. Then packaging is sealable conditions. Then lepas tu for this case kita give a rate kita based on DC6. Okay, using DC6 will be used for this palletized truckload shipment. Then kita step 1, 2, 3, 4. Okay, kita dah buat. Then lastly, write the test plan. What you want the test plan? This is the one. Okay. Second one, first kita nak buatkan mechanical testing. Sebab this is a very clear line. Dia kena untukkan AST, kena untuk first kita nak go through kan dia punya round test cost. Contoh dia punya apa? Untuk dia punya handling. Okay, shipping handling. Number 2, dia procedure P untuk AAO. Dia panggil horizontal impact. Impact. Then untuk number 3 dia rotation drop. Ini semua yang drop testing untuk 6179. Then follow number 2 sequence number 2 dia akan guna stacking vibration. Okay, dia akan stacking vibration. Dia kena ikutkan standard ini. Then what is actually duration for 180 minutes and then what is a profile. Last then number 3 sequence ni handling mechanical. So, dia akan pick up transport semua ni dia akan ikutkan procedure A sama lebih kurang yang sequence 1. Sebab dia go stacking, dia go through lagi. Because this is actually simulation exactly dia yang barang yang hantar sampai ke user. Then lastly, dia untuk warehouse stacking. Dia akan untuk stacking test. Dia akan compression test. This is a standard dia akan bagi tahu. That's why this is a writing the test plan. Then number 6, dia akan selectkan bagaimana kita nak select sample. Sebab kita tak boleh pilih. Kita nak tahu how you sampling the sample. This is also one of the procedure kita nak tahu. Kita ambil yang critical sample untuk yang determination, yang untuk represent yang whole lot. Then lastly, step number 7, the condition sample. Sebab sample is all collected, kita nak condition. Sebab condition tu banyak cases dia orang tak buat. Untuk packaging tu, especially paper, dia absorb moisture. That's why the condition very important. You kena condition sebab dia akan sama. Make sure kan dia punya result repeatability, kena reproducibility akan less than 2.8 times of square root repeatability dia punya standard deviation. This is one of the criteria, acceptance criteria. Then lastly, habis tu kita akan perform test for according to tadinya. Step 1, sequence 1, 2, 3 kita buat semua ni. Okay, plan in number 5 tadi yang buat. Dan kita evaluate lah apa yang dia sebut tu, dia nak minta kena buat macam ni, kena buat macam ni, dan kita make sure tak ada failure through the whole process. Number 9. Then last tu kena buat report. This is what actually the performance report kita nak kena buat yang produce untuk yang certified yang produk ni safe tak. And this is actually product panggil apa? Dia punya packaging engineer yang kena design. Sebab this is a step kena write down. Why kita yang performance itu kena buat yang validate tu very important. First thing, kita nak minimize the risk. Number dua, kita avoid expensive testing. Sebab kalau di testing tu akan cost tinggi. Kita nak avoid. Dan number tiga ni, yang enhance your customer confidence. Sebab kalau buat ni, customer akan confident. Okay. Yang lastly very important tu, kalau kita buat yang appropriate performance testing tu, kita akan reduce cost, improve yang acceptance of your goods. Okay, this is actually very important untuk minimize dia packaging testing. Basically, this is the one I need to highlight. That's why untuk packaging engineer, you can go through the perfectionist yang testing, yang penting juga. Dan kita nak follow yang very important is actually validate. Dia punya result testing tu kena validate. And at the same time, for me, I have actually done a lot of technical trainings, especially on the appropriate standard in various countries. For example, Taiwan, Myanmar, even go to China, Taiwan, Iran, and so on. And I do a lot of talking on technical speech on especially on the technical testings and application, mostly on application, not general, on application testings. And also make sure that it's actually compliant with ISO 75, maksudnya accredited. How you can make sure that yang testing tu dia boleh accepted atau accredited atau dia boleh yang report tu boleh terima dalam di court, boleh terima dalam court. Okay, this is I have end my topic. I hope that I don't know whether you have any question to ask.
All right, thank you, Mr. Fusang, for your interesting presentation. So, for me, I think it's kind of interesting how the presentation about the future trend itself. Now, I'm honored to open a Q&A session from everyone, from student. I personally want to ask myself a question for Mr. Fusang. So, the question is, how long can corrugated board last for per logistic? Let's say furniture without losing its structural integrity.
I did not hear you very clearly. Can you repeat again?
Okay. How long can corrugated board last per logistic? So let's say the logistic is a furniture.
Okay.
So how long can it last without losing its structural integrity?
Okay, this is actually very interesting questions. I think I have mentioned that most of the things people actually only referring to the stacking load, okay, or on the compression load. Basically, it doesn't able to adjust based on just one data. As I mentioned on the last slide, we have several of the testing have to be carried out because you see how ensure that the packaging for the furniture is safe when you arrive to a customer base, right? This is your question, right? That's why very important that we have to make sure first thing the material, the box, your corrugated box, what sort of fluting are using, and they actually capable to minimize the water absorption. Because when you water absorption very high water absorption, they will cause softening of your cartons. And number two, you will reduce the strength. And number three, and also when you softening, when you go through the transportation and so on, through the vibration and shocking and so on, there will be further damage to further weaken their carton, where you will be cause the damage on their products. How you're going to improve that is we have to go through a testing, meaning that how you're going to do a testing is first thing we have to go through the climate test, whether are you capable to withstand the climate. How you're going to do that is actually climate is actually we have to go put into a chamber, humidity chamber, and see after certain time for example, you predict 30 days. We have to put in the certain numbers. You already have a value. We can give you factors. You can actually simulation, we call acceleration. After Q10 or Q20, we can calculate from the simulation. Then, for example, you only do 10 days. We can from the graph log. We can actually work it out how long the thing can be sustained. First thing. Number two, we can go into a number of cycle tests. For example, the drop test and so on. are they capable? Because later on we can apply the for this simulation for how many hours. Because of course for transportation we're not going to test on this. For this we actually have certain cycle or certain amplitude, and we can do the simulation for certain minute time and see how the thing whether it can protect. That's why you can see there's number of cycle, distribution cycle to do a test. From there we can confirm that. And this is the one because of course for these testings, normally not only the engineer have to do that, you have a machine as well. And we actually would like to, the UDSM to look into this one, to come up the, to have a team where actually to help the industry, because industry shortage of this support. Because industry, they doesn't have the time to develop all these things. And they are actually looking for something, institution or university to help them. They can pass you a thing and then you do all these things. And we actually try to, if possible, we can try to work together as a team, and we can assist you. And then we can do the simulation, because we can do simulation plus the actual testings and determine. That's why I hope I answer your questions.
Maybe one last question, Shafiq, at the chat box.
All right.
Before we photo session.
Okay. So this is the last question. Before we proceed to the last question, I want to remind all the participants to fill up your attendance down the link below in the comments. All right. So for the last question, and question by Sazwan Saidin, he asks how the variety of fluid structure can affect the durability and the capability of the packaging.
Okay. You see, the floating, just now I think I've shared some knowledge. There's several of floatings. Okay, for several of floatings. How you ensure that the durability is also depend what is applications. For example, the smaller floatings, they will be much more durable, but the absorption is less. That's why we have to know their real applications in order for you to justify. For example, I take examples, a TV. I cannot use a float E, because it's too small. They cannot absorb. And this is the case, you might damage it. I have to use a bigger floating where it can absorb the things. But again, when you're using the bigger float, you won't be able to keep too long. First thing, because of this, they will be deformed at a certain time. That's why you have to modify certain factors to make sure that you won't over the factors. In most of cases, they are, a lot of electronics now, they actually need to know the factors, and they have to know how long the amplification the thing to be can go up. And most of the things they're already looking at something like 6 months to 1 year. Whether the same, if it actually they can go to this for this float, for example, maybe the double float will be safer, because double float there will be double different floating. Where this is how we actually work it out from the two different floating, and we can determine the durabilities. And we have to do a testing actually from the testing, for example, using the ECT, we can determine the durability by using different floating or combinations. I hope I answered the questions.
Okay, I think so. So with that last question, we ended our program today. But before that, we need I would like to invite all of our guest speaker and all participants today for a photo session. So please open your camera and your webcam for a quick photo session.
Okay, can everyone on their camera before we take the photo?
And smile,
Okay,
please.
please, anyone that close the video can open your camera. Okay, 1, 2, 3, first page. Okay, one more.
Okay.
1, 2, 3. Okay, that's all.
All right, with that photo session, ladies and gentlemen, we have now come to full circle of our industrial talk today. I hope you have found this afternoon program informative and useful for your future endeavors. So, we would like to thank you for your participation and support of the program. Thank you.
Thank you.
Thank you very much, Mr. Eng.
Yeah.
Good job.
Thank you,
Thank you
Mr.
very
Eng.
much. Thank you.
Thank you, doctors. Thank you, Sophie.
Thank
Thank
you,
you,
everyone.
doctors.
Thank you, James.
Thank you, James.
Thank you, James and
Thank you,
everyone.
Leo.